Yeah, we're still on the same standard, algebra, reasoning, and equations, and it says understand solving equations as a process. We still have been solving multi-step equations. Today we're going to continue with that. And also we've been addressing two standards, the math practice standard number 6, which is attentive precision. That's why when you work on those word problems, at the end you need to give me a statement. And math practice standard number 7, looking for structure, how to combine stuff and connect stuff to the big picture, such as numbers with area models and stuff like that, right? All right. And our objective for today, I can solve and graph multi-step one variable equation. Isn't this the same as yesterday? Yeah, the only thing today, we're going to add more steps. Yeah, and as we continue, they continue growing and growing. So that's why I need you guys to stay focused and do. I'm going every step of the way so you guys can see all the little steps before we get to the big ones. Okay? So, what concept are we on? Tell your neighbor, please. Right, we're still on one variable equations. We already know what those are. That's why we're not going to write this. We already know our steps, which is simplify, isolate, plot, check. Simplify, isolate, plot, check. Simplify, isolate, plot, check. Okay, so we got that, right? So, to simplify, we start with grouping symbols and combining like terms. So, just to recap where we've been, check this out. Yesterday we did, some of the properties that we're looking at. Everybody look up, please. When we started with equations, you actually were introduced to these properties last year, but I'm going to revisit these. Whenever you add something to each side of the equation, that's called the addition property of equality. When you subtract something to each side of the equation, it's called the subtraction property of equality. So what is it called if I multiply each side of the equation? Multiplication property of equality. And if we divide something to each side, with division property. They're straightforward. That's why there's no formal introductions, just so that you understand that everything that you do in equations has a property. Okay? However, we also have been working with commutative property. Is that correct? Associative property? Distributive property? Yes. Also, at the beginning, we introduced zero product property when I introduced zero pairs. Before I did that, I said whenever you have 2 or 3 numbers that multiply, but one of them is a 0, the answer is always 0. Remember that? And then also we introduced exponential property. So we've covered a bunch of properties already, and it's barely the first month down. So we still have more to go. Yes, and throughout the year, we're going to keep adding. And towards the end, when I ask you to justify your step, you need to remember the properties. We're going to continue using the properties. Yes. A little bit more. They might be, I think, like 23. Anyways, here we go. So what have we done? Check this out. We're also going to be doing some window notes, and I'll show you that later. We've done these, right? And on these, you draw your line down, combine like terms, and then you solve. Same thing with this one. Line down, combine like terms, and solve. We've done these. Get rid of the grouping symbol, is that correct? We distribute, simplify, and solve. Are we there? We've done these. And this one, I just wanted to revisit this one. On this one, there's an invisible 1 here, so this is -1. We distribute this. This becomes -4y minus 8. I bring down the 10y, that equals a -20. From there, can I combine like terms? Yes, that is 6y minus 8 equals 20, and we know what to do from there. Is that correct? Okay. So, also 2 lessons ago, we did these. What happens to these? We multiply times 3 both sides, and then we continue solving, right? Same thing with this one. Is that correct? Multiply times 2 both sides and continue solving. Okay, and that's where we arrive here. Copy this one down, please. Example number 7. Solve. 7n minus 2 equals 5n plus 6. 7n minus 2 equals 5n plus 6. All right. Guys, focus, please. Pens down, eyes up here. Check this out. I'm going to draw my line down the equal sign. Once again, as equations continue growing, that helps me focus and know which side I'm on. Some of you are starting to make mistakes after this example, and I'm going to show you where, so like that you avoid it. Can I simplify this side of the equation? Let's see. Can I combine like terms? No. Do I have any grouping symbols? No. How about this side? Combine like terms? No. Grouping symbols? No. But your brain right now is telling you, I can combine this one with this one. That is incorrect because they're on two different sides of the equation. You can only combine like terms if they are on the same side. I'm being specific with this one because this is the main mistake that most of us make. Okay? So don't do that. Don't combine that. So then what do? It says simplify. We're done with that. Step 2, isolate. What does that mean? Leave the variable by itself. So you're saying, yeah, but well, now we have two variables of the same kind. Well, therefore, we need to get them together. What's the smallest variable that you see? Variable. 5n. So we start there. If it's a positive 5n, to cancel this one, we do the opposite. What is a It's a negative 5n, and whatever we do to one side, we do to the other side. We're left with 2n minus 2 equals 6. Do you know what to do from there? Copy that, please, and finish, please. All right, so let's see. From there, you should have add 2 to each side. We bring down the 2n equals 8. And at the end, we divide by 2, divide by 2. 2 over 2 is 1 times n is n. This is 4. Hands, have you got that? Okay. So what is the only step that you need to worry about? The first one of getting all variables to one side. Now, check this out. If I was to start with a different way, I still will get the same answer. And let me tell you why. When we introduced equations, didn't I introduce equations with a scale? Yes, I showed you the scale. And I said the reason equations are equations is because we keep it balanced. Is that correct? Whatever we do to one side, we do to the other. Doesn't matter the operation, but whatever we do to one side, we do to the other. So if I was to go back to this one, and instead of starting with the smallest variable, what if I started with, let's see, what if I started with the number, and I wanted to get rid of this one? What do? Add 2, we're left with 7n equals 5n plus 8, and then the next step. Is that correct? And I still come up with the same answer. Or, check this out, what if I was to start with, what if I was to start with the 7? Subtract 7, subtract 7. We're left with negative 2 equals negative 2n plus 6, and then add 6 to each side. We still come up with the same answer. The only difference, check this out. Who notices now that I'm working with negative numbers on the variable? And who noticed on the first way that I showed you that we don't have negative numbers here? Everybody see that? So the reason I'm asking you to start with the smallest variable so you can avoid a lot of mistakes using negatives throughout. So everybody see what I'm saying? Even though we can come up with the answer either way, starting with either number, I want you to start with the smallest variable. Yes? All right, do this next one by yourself. Here we go. Example 8. Copy that one. 5b plus 2 equals 3b plus 8. See what you get for that one. Go step by step. First steps first. I'm going to draw my line down the equal sign just to keep organized. Can I simplify this side anymore? No. This side, no. That means I'm going to get all variables to one side. What's the smallest variable? 3b. So therefore, if it's a positive 3b, the inverse is subtract 3b. Subtract 3b. We're left with 2b plus 2 equals 8. So far, so good? Minus 2 minus 2. 2b equals 6. And the last step, divide by 2, divide by 2. B equals 3. Hands, have you got that? Okay, good. So far so good? All right, so check this out. Let's go to these next ones. Don't copy this one. It's the same process, but just with decimals. But I want to get to this one. Example number 10. Copy this one, please. It says, solve the equation 4 minus 6a plus 4a equals negative 1 minus 5 times 7 minus 2a, close parentheses, only. Okay, here we go. So I'm going to draw my line down the equal sign, and we're going to do this one together. Since most of it, we already know what to do. The only thing now we have more stuff, okay? So right now I'm going to focus on the left side of the equation. And it says simplify by combining like terms or grouping symbols. Do we have any grouping symbols? No, but can we combine stuff?
Yeah.
Yeah, these two right here. Negative 6 plus 4, that's what? Negative 2a. I bring down the 4. Look at these two. Can I combine anything else here? No, I'm done with this side. Now let's move on to this side. Grouping symbol, is that correct?
Yeah.
There's a 5 in front of it, but what symbol is in front of it? The negative. This becomes a negative 5. Remember what I said? From this point forward, when it has a negative, circle it together with a number. Okay, let's distribute. Negative 5 times 7, that's negative 35. Negative 5 times negative 2, that's what? Positive 10a. Bring down the negative 1. Can I simplify this side anymore? Yeah, combine like terms, is that correct? So therefore, negative 1 and negative 35 becomes negative 36. Bring down the plus 10a equals 4 minus 2a. Can we simplify this side anymore? No. So at that point, now we start with the next part. Get all variables to one side. What's the smallest variable? Yes, child. Negative 2a. So what is the opposite of a negative 2a? Positive 2a. Whatever we do to one side, we do to the other. This is 4 equals negative 36 plus 12a. See if you can finish it off from there. Go. All right, help me right here, Jessica. What do I do? Okay, let's see. To solve for a, what do we need to do? So we need to get rid of the negative 36. So what is the opposite of a negative 36? Positive 36. Whatever we do to one side, we do to the other side. Thank you. So this is 40 equals, bring down the 12a. And what do we do then, Gustavo? No, Gustavo. Divide by 12, divide by 12. A equals, 12 fits in there 3 times, and we're left, let's see, 12 times 3, that's 36, to 40, that's 4 12s. Or, if you simplify, this is 3 1/3 equals A. Or, if you went decimals, 3.3 bar equals A. And so if you got that, okay, pretty good. Okay, let's continue. Let's go to the next one, number 11. Copy this down, please. Example 11. Copy that. Solve. It says 1/2 times b plus 6, close parentheses, equals 3/2 b minus 1. Homework didn't have one just like this because it only had variables on one side. Very similar. Okay. So let's do this one together. Here we go. Line down the equal sign. Okay. Simplify each side. Start with grouping symbols. Right here, there's a grouping symbol. So I'm going to multiply this one in here. What is 1 times b? B over 2. Plus, what is 1 times 6? 6 over 2. Equals, this stays the same, 3 over 2, b minus 1. Now, I don't know about you. Do you want to continue working with fractions all the way? No, let's get rid of the fractions. What's our common denominator? 2. So let's multiply the entire equation times 2. 2 times b, that's 2b over 2. the denominator stays the same, plus 2 times 6, that's 12 over 2, equals 2 times 3, that's 6 over 2b, minus, and 2 times 1 is 2. Let's simplify those. What is 2 divided by 2? 1, and we're left with b, plus 6 equals 3b minus 2. Do you know what to do from there? Finish it off, please. See what you get. Okay, let's see. We need to get all variables to one side. What's the smallest variable? 1b. So the inverse is a negative 1b. Negative 1b. So we're left with 6 equals 2b minus 2. So far, so good? From there, we need to get rid of this 2. So therefore, I add 2, add 2. We're left with 8 equals 2b. And at the end, I divide by 2, giant 1, 4 equals b. Hands if you got that. Okay? So far, so good? All right. No, that's fine. Okay, let's continue. Copy that one, please. See if you can do that one by yourself. Go one step at a time. Remember, if you have difficulties looking at the entire equation, draw your line down the equal sign so that you know where you're at. Okay? Here goes the process. Line down the equal sign. Look at this side. Can I combine like terms? Yes. Looks like right here. 15 minus 9, that is positive 6. Bring down the 3x. Can I combine anything else? No, I'm done with that side. Move on to the next. This one, grouping symbol, I distribute. 2 times x is 2x. 2 times 2, that's 4. Since I cannot simplify anymore, now I'm going to get all variables to one side. What is my smallest variable? The 2, the positive 2x, so I subtract 2x. Subtract 2x. We're left with x plus 6 equals 4. In our last step, to leave the x by itself, I subtract 6, x equals negative 2. Hands, have you got that? Okay. Check your steps to make sure you see where you made a mistake. Now, once again, the common mistakes are right here. Everybody look up, please. Some of you, you start making mistakes here because you forget about your integers rules, right? Remember we did 0 pairs and all that? Make sure you use those here. That's when we start paying more close attention to them. All right. Now, we get to this part. Copy this one. Solve the equation 10 minus 5x plus 1 equals 7x plus 11 minus 12x. 10 minus 5x plus 1 equals 7x plus 11 minus 10x. Minus 12x, I'm sorry. Check this out. Let's do this one together. Look at this side right here. Can I do anything to this side?
Yes.
Yes. Combine like terms. 10 plus 1, that's what? 11. It's a positive, and I bring down the negative 5x. Can I do anything else? No, I'm done. Okay? Look at this side. Can I do anything to this side?
Yes.
Yes. 7x minus 12x, that is negative 5x. And I bring down the plus 11. Okay? Pens down at this point. Check this out. Look at this. The next step, or we look up, if I was to bring this variable over here, I need to add 5x, well, what's going to happen? It's going to cancel here, and it's going to cancel there. You're going to end up with, oh snap, 11 plus 11. I mean, positive 11 equals positive 11. Check this out. When you get to this point, when you see that this is identical to this, this is what we call identity. And what does that mean? What that means, everybody look up, is that if I was to substitute values for x, I'm going to continue getting the same thing on each side. So check this out. What if I substitute 0 here? What is 0 times negative 5? 0, and I'm left with 11. But don't I need to substitute 0 here also because it's x? So I end up with 11 equal 11. Don't we end up with the identical thing? Yes. That's why this is called identity. So you're going to get a couple of those in the answer is you don't solve it, you just write identity. Okay? Homework is found on pages, what? 95 to 96, numbers 1 through 35 odd. Have a good one, guys. Enjoy your homework. See you guys tomorrow.